All right, so what we're going to do is we're going to go back and we're going to make sure that everybody can add and subtract, multiply, and divide just some basic polynomials. We're going to talk about some of the terms of the polynomials. As I was looking through the test and the homework questions earlier today, some of these things are kind of thrown in there, so I wanted to make sure that you had access to this information. Okay, so we have our examples of a monomial. A monomial can be a number, the product of numbers and variables. So these are all three different monomials. And notice that in our exponent rules, when we multiply like bases, we change the exponent. This exponent changes with multiplication. When we divide, our exponent changes. Negative exponents are not allowed unless you do scientific notation. And then anything to the 0 power is 1. And when I say anything, I mean anything. 2 to the 0 power is 1. If you had x plus 4 and you had a 0 exponent out on the outside, that is also a 1. So anytime you end up with a 0 exponent, whatever that 0 exponent is attached to turns into a 1. All right, and then I've given you some examples of each one of these exponent rules, and we're going to apply the majority of those in our examples today. So in the first section, we're doing some multiplication. We do some negative exponents, so we're going to apply all those rules above. So when you multiply two monomials together, when you multiply, the number changes and the exponent changes. So I'm going to multiply 5 times negative 7. That gives me negative 35. And when you multiply, you add those exponents. So I get x to the 8th. 2 plus 6 gives me 8. So the front number changed and the exponent changed. That's what happens when you multiply. All right. When you have an external exponent, when you have one that's attached to an outside of a parentheses. Now, that's a monomial inside that parentheses. That is not the same as negative 2 plus a square. This is a binomial, and the rules for binomials are different. This is a monomial term. It's a product of numbers and exponents. So what we're going to do, everything in that parentheses gets the 2. Now, I'm going to write down what you should be thinking when you work through just this part of the problem. I'm about to write down. You should be thinking negative 2 squared gives me 4. You should be thinking a to the 3rd squared. You multiply those two numbers together, it gives you a to the 6th. That's the rule. If you go back up here, when you have that outside exponent, you multiply those two exponents together. You don't add them. And then I should be thinking b to the 2nd power is b squared. So all of that turns into 4a to the 6th b squared. Multiply that times 8 ab to the 9th. So front numbers change. 4 times 8, 32. Now that I'm straight up multiplying, I'm just going to add the exponents. 6 plus 1 gives me a to the 7th, and 2 plus 9 gives me b to the 11th. And that would be my final answer for number 2. Before we do number 3, I'm going to go kind of out of order here. I am going to do number 4 because it looks very similar to the first one that we did. I am straight up multiplying these two terms together. So 2 times 10 is 20. And when I take 4 and add it to negative 7, I get k to the negative 3 power. I can add positive and negative numbers together. What I can't do is leave a negative exponent. So my negative exponent rule says that if I have a to the negative m, I'm going to write it as 1 over a to the positive m. That's one of the rules that you copied down. The 20 does not move. The only thing that moves is the k, because that's the only thing that has the negative exponent. So I'm going to drop that to the bottom and make that a positive 3. That would be my final answer for that particular problem. Now, if you want to write it out into two pieces, you can do 20 times 1 over k to the third, and then you would still multiply the 20 and the 1, you still get this answer. So either way you want to think through that one is fine. All right, so some monomial division. When you multiply and divide monomials, the numbers change. What is 54 divided by 3? Got to change that number. 18. Now, our rule says if you have a to the m divided by a to the n, that becomes a to the m minus n. When you start subtracting, you do have the option of getting negative exponents. So I'm going to take that 2 up. My thought is m to the 6 minus 2, which gives me m to the 4th. This is my thought. If you don't have to write that down, don't write it down, but I'm just writing down what my thoughts are. Then my n, I have a 1 on the bottom. I'm going to take it up. So I'm going to have n to the 4 minus 1 equals n to the 3rd. So when I simplify this entire fraction, I end up with 18m to the 4th, n to the 3rd. Now, this is the first time we've had subtraction come up. And if you recall, I wrote down up here, when you add and subtract, the numbers change, but the exponents do not change. In order to add these together, the exponential part of it has to be the same. I have m to the 4th, n to the 3rd in both of them. So I'm just going to take those front numbers, subtract them. 18 minus 10 is 8. M to the 4th, n to the 3rd. Exponents do not change when you add or subtract. Only when you multiply or divide. All right. So I want you to do number 7. We'll backtrack to these two in just a second. This is just a division problem. So the front numbers should change and the exponents are going to change. All right, so 15 over 24, both of those numbers are reducible by 3. Do y'all agree? So that would be 5 over 8. We still have a fraction. If I take this up, that gives me x to the 10 minus 12 power. That gives me x to the negative 2 power, which can't stay negative 2, so I'm going to drop it to the bottom of that fraction and make it positive. This 3 goes up, and I should be thinking y to the 4 minus 3 gives me y to the first power, so y stays in the top. The only time you do not leave something in the numerator is when it's a negative exponent. All right. The next one I want to do is number 6 because we have a negative exponent on the outside. That negative exponent on the outside tells me to flip the fraction. So I'm going to rewrite this as 7w to the third over 14w to the 12th to the positive power, to the positive 1 power. Since it's to the positive 1 power, all I did is I flipped that fraction and changed the outside exponent to positive. Now I can reduce it. 7 over 14 reduces to 1 over 2. If I take 12 up, I should be thinking w to the 3 minus 12, which is w to the negative 9. Where does w to the 9th go? Does it stay in the top or drop to the bottom? It goes to the bottom. So that is my answer, 1 over 2w to the 9th. All right, I know I'm going out of order. So now we're going to backtrack and get number 5. I have an outside exponent. I have to deal with that first. So my thoughts are over here. 2 over 3 squared is 4 over 9. 2 times 2, 3 times 3. R to the second squared, multiply, and you get r to the 4th. S to the 7th squared, multiply, you get s to the 14th power. All right, there is no outside exponent for the second one, so we're just going to write that down as is. So I'm going to multiply those two front numbers together. So 4 over 9 times 1 over 6 gives me 4 over 36. No, it does not. What's 9 times 6? Because it definitely is not 36. 54, and both numbers are divisible by 2. So that would be 2 over 27. I have an r to the 4 plus 3 power. R times r, you add the exponents. That gives me positive 7, so it stays on the top. And I have s to the 14 plus 1 power. 14 is here, 1 is here. So that gives me s to the 15th power. And that would be your final answer for number 5. Lots of exponent rules. So for number 8, we have exponents on the outside. So I should be thinking c to the 4th power. That gives me c to the 4th power over c squared to the 4th power. What do I do with that 2 and 4? Add, subtract, or multiply? Multiply, so that gives me c to the 8th times, I have another exponent on the outside, so negative 3 to the 4th power is negative, sorry, it is not negative, it is positive 81. And c to the 4th power just stays c to the 4th power. Any thoughts on what we could do next? There are several options that we have. Say that louder. Subtract those. Okay. So c to the 4 minus 8. I can do that. That's a legitimate property. Take that bottom number up. That gives me c to the negative 4. So what I have at this point, I have c to the negative 4 times 81c to the 4th. Now, c to the negative 4th power becomes 1 over c to the 4th. Do y'all agree with that? So I'm going to take that out and put 1 over c to the positive 4 power. So what we did, what was suggested, is a legit mathematical step. How do I multiply something that's a fraction with something that's not a visible fraction? Say it again. All right, put it over 1, multiply straight across. So we have 81c to the 4th over c to the 4th. What happens to both of those c to the 4ths? They cancel. So my final answer, all that work for 81. All right. Now, on the next page, there are some terms towards the bottom, and I'll give you those in just a second. But let's focus on 10 through 12 at the moment, because this is going to be extremely important when we go to solve some of our polynomials that I kind of skipped over today. So polynomials are just a bunch of monomials added and subtracted. The highest exponent is called the degree, and the degree matters. It has relevance into what we're going to do this week and next week. The largest exponent has a job to do. Okay? Now, standard form, it says to always write your exponents in descending order. Now, number 10 only has one variable. Do y'all agree? So we're going to go through and we're going to pick each k term from the biggest exponent down to no exponent. So negative k to the 5th, that's the biggest exponent I see. The next one in line is negative 3k to the 3rd. You do not have to have a k to the 4th, but your exponents need to count down. Then we're going to have our positive 1/4 k squared. We're going to have our positive 8k. And then, of course, at the end, you always put the constant number that does not have a variable. All right. How do you organize something that has two variables? Alphabetically. We're looking at the A terms. In this problem, we have A and B, so you always go with the first letter in the alphabet, or the letter that comes first in the alphabet. And what is the biggest exponent on A? Okay, so we're going to put that 4a to the 3rd first. When I look across that problem, what term has the second biggest A exponent? All right, so my 18a squared, the b squared just kind of tags along for the ride. I have two left. Which one do you think is going to come first? The 7ab, and then the one with no A would go last. All right, so I'm going to give you a moment to do number 12. X comes before Y in the alphabet, so you're basing this on the exponent for X. constant numbers always come last. So I built this polynomial based on the exponent attached to x because x comes before y. Any questions about that? All right, so another thing that Math Excel is going to ask you to do, because I checked and there are a handful of these questions scattered throughout. Classify your polynomials by degree, which is the highest exponent. And then we're also going to do it by the number of terms. So here are the degrees all the way up to the fifth. This is what they're called. If you do not have a variable, that is a constant term, 0 degrees, because there's no variable. Now remember, this column represents the exponents. This column represents the largest exponent in your expression. All right, so when they ask you to classify by degree, you need to pick one of these titles, okay? So here, the biggest exponent on x I see is a 1. So that is classified as a linear polynomial. As far as the number of terms, monomial, binomial, trinomial, or polynomial, I have 2 terms. And I know I have 2 terms because those 2 terms are separated with addition. So this would be a linear binomial. All right. Classify by degree. The biggest exponent I see is 5. So that is considered a kintic polynomial. How many terms does that polynomial have? 3. So that would be a trinomial. All right, and we will finish this page when we finish lunch. All right. Now, we talked about adding and subtracting polynomials. You add those front numbers. You do not change the exponents, okay? So I'm going to give you a moment to work number 1. Y'all do have that page in your packet, correct? Okay. All right, and that's what I ended up with for the first answer. What I did, since we were adding, I dropped the parentheses altogether, kept all the signs, dropped the parentheses, added like terms. Notice that the exponents did not change, but the front numbers did. Now, subtraction, excuse me, you have to be extremely careful with subtraction. Okay, what I would do is I would, since there's an understood one here, drop those parentheses, take the time, because a lot of times when we do subtraction, We miss a sign, so one of our numbers is wrong. I'm going to take that and distribute it across the parentheses that follows it, just the one that's directly behind it, which means every sign inside is going to change to the opposite of what they are now. So that would become negative 2k squared minus 2k minus 17. If any of those were negative, they would have turned into a positive. They changed to the opposite. And then I can go through and combine like terms. There is not another k to the third term in the whole list. Do y'all agree? So I have negative 2k squared, and negative 2k squared combines to negative 4k squared. Notice the front number changes, but the exponent does not. Then I have 2k and negative 2k. They will cancel. 2 and negative 2 become a 0. And then the last thing we have is the negative 17 at the end. Notice that my answer is written in descending order, biggest exponent down to the constant term. Everybody okay with that? Any questions about that? All right. Now, distributing and foiling. You have done that before. So for number 6, we are going to multiply w minus 7 times w squared plus 2w plus 1. So this is what I call extended FOIL, because typically foiling is when you have two terms, a binomial times a binomial. So I'm going to take w and I'm going to distribute it, multiply it. Multiplying changes exponents. So w times w squared becomes w to the third. W times 2w becomes 2w squared. W times 1 just stays w. I'm going to do the same thing with the negative 7. I'm going to multiply it times everything in that second parenthesis. So that's negative 7w squared minus 14w minus 7. And from here, you are going to combine like terms. I see no other w to the thirds. I see 2w squared and negative 7w squared. That gives me negative 5w squared. I see 1w and negative 14w, which would combine to give me negative 13w. And then, of course, negative 7 stands alone because there's nothing else to do with that one. All right, the next problem on this page that I want us to do number 7. I do not think you have any problems like number 8 and number 9. I will double check that, and if you do, we can backtrack and get that tomorrow. So I have a FOIL that I have to do here, and I have a distributing scenario second. So I'm going to do the FOIL part first. 2x times 4 is 8x. 2x times negative 9x is negative 18x squared. 1 times 4 is 4. 1 times negative 9 is negative 9x. Now, I'm not going to add any of that together because I'm going to have to add the result from this as well. So negative 2 times 3 is negative 6x squared. Negative 2x times 11 is negative 22x. So I got my 4 terms from foiling and my 2 terms from distributing. Now, I have an 8x and a negative 9x, which gives me negative 1x. Negative 18 and negative 6 give me negative 24x squared. I missed an x, so I'm going to have to go back and grab that one. Negative 1 and negative 22. that will give me -3. I missed it, overlooked it altogether when I were adding my other two x values together. So -1 and -22, that gives me -23x minus 24x squared plus 4. Now, that is a legitimate answer. The only problem is it's not in standard form, which means the biggest exponent is not first. So I'm just going to switch these two. So that would be -24x squared minus 23x plus 4. This is the standard form of your answer. Is this wrong? Absolutely not. Those are the correct three terms. They're just not in the appropriate order. Does that make sense? All right. And then the last thing that we are going to do is just go back over quick review of dividing by a monomial. Now, part of what we're going to do tomorrow will be picking up dividing by a binomial. And I don't know if you got that far or not last year, so we're going to start from scratch with that. But as far as a monomial, this is a one-term denominator. So what I'm going to do, y'all have that page in your pocket? Okay. So what I'm going to do, I have a binomial numerator and a monomial denominator. So I'm going to break it up into two fractions. So 9m to the third divided by 3m minus 24m squared divided by 3m. And then I'm going to reduce each one of those fractions individually. Now, if it reduces all the way down to just like one term, that's fine. If it simplifies and you have a fraction left, that's okay. But you've got to try to simplify both fractions. So my thought is 9 over 3. That's my thought. Gives me 3. M to the 3 minus 1. There's a 1 right there. It goes up. So that gives me 3m squared for the first fraction. Then I'm going to do the same thing here. 24 divided by 3. That gives me 8. I am going to take that 1 up and subtract it. So m to the 2 minus 1 just gives me m. Now, these are not like terms because this is an m squared and this is not. So this would be your final answer. And notice how it is in standard form already. If it's not, make sure that you do rewrite it and organize your terms in standard form. Now, numerator, 1, 2, 3 terms. Denominator, 1 term. So I've got to write down 3 separate fractions and reduce each one individually. So I've got 20x to the third divided by 4x minus 4x squared divided by 4x minus 8x divided by 4x. So my thought, 20 divided by 4 is 5. X to the third over x to the first. Take that up and subtract it. It gives me positive 2, so I'll leave it alone. Minus 4 over 4, which is 1. X squared divided by x. That 1 goes up, and 2 minus 1 gives me x. And then I have 8 divided by 4, which is 2. And what does x over x become? It cancels, right? So there's no x on the tail end. These terms are in standard form. Everybody okay with that? Any questions about that one? Yes, ma'am.
Could it just be x instead of 1x?
That's exactly right. I was just heading in that direction. But yes, you do not always have to put that 1. It's understood to be there. And as a math Excel would prefer that you did not have the 1 visible. it should accept it, but it might give you a little message that says, oh, remember, ones don't have to be type 10. All right, and the next one off of this page that I wanted to do was number 8 or 18. I have 2 terms in the top divided by 1 in the bottom. So that means I have 2 fractions that I have to set up and I have to reduce. The reason I chose this one as opposed to the other 3 is because this one we're going to end up with variables in our denominators for some of these. All right, so for the first fraction, my thought, 40 divided by 8. You don't have to write it down, but that's what you should be thinking, is just flat out 5. Then I have m to the third divided by m squared. Take that 2 up, and that gives you m to the first. 3 minus 2 is 1. As long as the exponent is positive, life is good. But watch what happens when I try to do that with the n. When I take 5 up and subtract it, I get n to the negative 1 power. You cannot have negative powers, so that drops to the bottom and becomes positive 1. Do not leave negative exponents. Same thing for the last one. We're going to put our minus sign there. So 24 divided by 8 reduces all the way down to 3. M squared divided by m squared cancels. Now remember, when you cancel it, it technically becomes a 1. It doesn't become a 0, but it becomes a 1. And then we have n to the 7th over n to the 5th. Take that 5 up and subtract it. As long as you get a positive number, the n stays put. If that had been a negative exponent, we would have dropped it to the bottom like we did the first one. Now, we're not as familiar with those type of answers. We're always, and we do this in Algebra 1, and I was guilty of it when we did algebra, when I taught Algebra 1. We try to make it to where every problem works out the way it should work out. We don't necessarily give you a problem that doesn't always work out perfectly and neatly. Okay? So, that was a lot of stuff. We added, we subtracted, we did some multiplication with monomials, we did some foiling, we did a little distributing, we did some division by monomials. So tomorrow we are actually going to backtrack, and we are going to go all the way back to the solving polynomial equations by factoring, and there is a division, a review of dividing by a monomial, and then the new stuff is dividing by a binomial.